Welcome to inverse functions. This video is going to take you through inverse functions, which basically maps outputs to original inputs. So what we're trying to say here is basically you just switch x and y. That's what inverse functions do. You switch x and y. So your inputs become the outputs and the outputs become your inputs. Here's the notation for the inverse function. It's f to the negative 1 of x. So it flips domain and range, but graphically, like I said, an inverse function is switching x and y, which means the inverse of a function is going to be a reflection over the line y equals x. So we're going to draw y equals x here for you, just so you can get an idea of what it looks like. And then we're just going to take a couple of points and show you what it's like when you take the inverse of a graph. So we have this blue line, and to see what an inverse is, we're just going to take a couple of the points and we're going to switch them up. So we're going to find the inverse of f of x here. So in the blue line, one of our coordinates is negative 2 comma 4. So that's going to turn into 4 comma negative 2. So we go to 1, 2, 3, 4 comma negative 2, and we're going to place a point. And let's take another one. Another one of the points we have over here is, well, we have 2, negative 4 instead. And that's going to switch to negative 4 comma 2. So we'll go to negative 4, 2. We have another point. Another one of the points we have is 1, negative 2. And that is going to switch to negative 2 comma 1. So we would go negative 2, 1. And then you can see that 0, 0 is just not going to switch at all. And this one would be 2, negative 1. And you can see that this is just a reflection over the red line y equals x. Those are inverse of graphs. Now, algebraically, it's pretty easy to find an inverse algebraically. Again, the phrase of the day is switch x and y. So we'll write this function as y equals 2x minus 4. So now all you have to do is exactly what I said. Switch x and y. So this becomes x equals 2y minus 4. Now all you have to do is solve for y again. So add 4 to both sides. This becomes x plus 4 is equal to 2y. Divide both sides by 2. And you get y is equal to 1/2 x plus 2. And you're done. So the final answer is written in function notation. We have an inverse function. So the inverse of f of x is equal to 1/2 x plus 2. And you are done. So that's how you do it algebraically. Again, just switch x and y and solve for y again. How to verify inverses. You verify inverses by taking the composition both ways. So what you're going to need to do here is you're going to need to find f of g of x, and you're also going to need to find g of f of x. And if both of those compositions give you x, then f and g are inverses of each other. Okay, so this is how this would work. So we would find f of g of x, so we would start with our 1/2, and now we have our x plus 1. And we're going to substitute our 2x minus 2. That's our g of x. And now we just simplify it out. So we distribute the 1/2. We get x minus 1 plus 1. And those are going to simplify to just x. So we've got 1 that's good. You still need to check it the other way. So now we're going to substitute f of x into g of x. So we have our 2. And then we're going to substitute in our 1/2 x plus 1. Distribute your 2, and you're just going to get x plus 2 minus 2, which they cancel, and you get x. So yes, f and g are inverses because they both simplify to x. Okay? So you have to find the composition of both. Remember, f of g of x must equal x, and g of f of x must equal x for them to be inverses. That's how you verify. So make sure you pay attention to what the question is asking you to do. If it tells you to find it, that's when you switch x and y. If it tells you to verify, that's when you do the compositions. So, the inverse of a nonlinear function. So, the blue graph there, that is f of x is equal to x squared. The domain is obviously all real numbers, but our range, y is greater than or equal to 0. As you see, it's never going to be below 0 because, well, first of all, since we're squaring something, when we square anything, it's always going to be positive. So what we need to do here, there's a couple ways you can do this. You can plot some points, or you can do it algebraically. Really, it's up to you. So if we were to plot a few points, this 1, 1 becomes 1, 1, but this negative 1, 1 becomes 1, negative 1. And we also have this 2, 4, which would become 4, 2. And we have this negative 2, 4, which would become 4, negative 2. And as you can see, you have a graph just by switching coordinates. So then you would have to ask yourself a couple of questions here. We can state the domain and range again. And another thing, though, you could do this algebraically. So we know that y is equal to x squared. So to take an inverse algebraically, we switch this to x is equal to y squared. Now to get y by itself, we just square root both sides, so we get y is equal to plus or minus the square root of x, which is what that graph is. So we have to state the domain. As we can see, y is going to go up and down, but look at our x. X is only positive numbers now because we can't take the square root of a negative. So our domain for this is going to be x has to be greater than or equal to 0. And our range is going to be y, where y can be equal to all real numbers now. And again, if you go back to the very beginning, inverse functions basically switch your domain and range. As you can see, that is exactly what happened right here. So that's pretty much the phrase of the day. Switch x and y, switch domain and range, switch inputs and outputs. Inverse functions just switch inputs and outputs. So here's another example for you. To do this, you would switch points again, or you can switch it and handle it algebraically. Either way you do this, you're going to have this point, which is 2, 8, would become 8, 2. This point, which is a negative 1 is going to stay the same. 1, 1 stays the same. But this is negative 2, negative 8, which would become negative 8, negative 2. And graphically, it's going to look exactly like a cubed root function is supposed to look like. So that is the inverse of f of x is equal to the cubed root of x. And that's what it's supposed to be. Now, you don't even need to look at the graph to state your domain since this was given. They're both, our domain and range, are going to be the exact same because all real numbers is going to still stay all real numbers for both. And that's it. So, if I were to ask you a question about is this graph a function and then is the inverse a function, you can use what's known as the horizontal line test. So we have y is equal to the absolute value of x plus 2 minus 3. If you remember how to graph absolute values, we would just go left 2 and down 3, and it's going to look like a V. Our domain for this would be x has to be all real numbers because there's no restrictions on what you can put inside of an absolute value. But since the absolute value is always going to go up because it makes what's inside positive, you just have to find out what x is or what y is going to be above this point. So y is going to be greater than or equal to negative 3. Do you see any values below negative 3 for y? Nope. So is the inverse a function? Well, you can regraph it or you can try the horizontal line test. And that's because we switched the x and y, we switched the line test, If it hits it twice, the answer is no. The inverse is not a function. This is a function. X, the absolute value of x plus 2 minus 3 is a function. But if we were to take the inverse, it would not be. And again, like I said, if you wanted, you can regraph this as an inverse, and it would look a little something like that. And you do the vertical line test, you would see that it would fail the vertical line test. But you can, like I said, just go straight to the horizontal line test, and it'll tell you if that inverse is a function. So what is our domain? Well, our domain, x is greater than or equal to a negative 3. And our range, y, is equal to all real numbers. And that's what the inverse would be, because all we have to do again is switch, or I'm sorry, all I asked for was the domain. All we have to do is switch and find out what it's going to be. But the range would be all real numbers. So that's it. This is inverse functions. I'm Longo, and I'm out. See you bye.